Right, so moving on to 7.2, this is about modeling with static particles. So we are going to apply the same technique and same method that we've learned last lesson about static particles. Just a reminder again, what does static particles mean? Static means equilibrium, not moving, okay? Particle means like a mass, like a block, something with a, just one mass. So static means equilibrium. Oops. Okay. Particles means a block, just a mass, okay, just a mass. So what is not a particle? So what you've done in moments is not a particle because it's a plank, it's a rod, so that's not a particle. Right, today's lesson is just about modeling with it. So we're going to play around with sort of more real-life application of what you've learned in a previous lesson, how to apply those calculations into a context. Example number 1, a smooth bead Y is threaded on a light inextensible string. So string means tension. The ends of a string. Now, be mindful in this one. That there's only one string. Okay, so if you look at the diagram on the right, X to Y to Z is all one string. The ends of a string are attached to two fixed points. X and Z are on the same horizontal level. The bead is held equilibrium on a horizontal force of magnitude 8 Newton acting parallel to ZX. So you see in here. Now, what it means is, it means this is all one string. This is all one string. So one string means the same tension. So same tension. The bead Y is vertically below X, and X, Z, and Y is 30 degrees as shown in diagram. Find the tension and strength and the weight of the bead. So the weight of the bead, maybe you can tell me where's the weight? The weight will vertically downwards will be here. And what else? Where's the tension? You got tension here. It's always pointing towards the point where the string was released or attached. So the tension is attached to point X and point Z, so it'll be pointing to point X and point Z. There'll be two tension here because it's threaded after it's threaded over the bead. There'll be two tension. However, they are the same T value. Unlike what you've learned in moments, let's say in here you've got point A and point C, you've got RA and RC. Now these two are different because they are separate reactions, separate string. Or you've learned about having a string in here and then a plank underneath it. You've got TA and TC. These two are two separate strings, therefore two separate tension, TA and TC. If they're the same string, you'll put them as T. But so this one, that's what I'm saying. So we'll put them as T for same T, no TA and TC for this question. They're both T. Okay, just T. Right, find the tension and strength. So we know it's equilibrium. Where's the word equilibrium? I'm looking for equilibrium. Right. So pencil, let's draw the axes. That's the axes. Okay. First step, resolve any force that is not on the axis. Right, we can see this tension. It's actually quite difficult for me to tell you which T I'm referring to, because in the classroom I would point to you, yes, this is the T we're looking for, but I have to show you on a computer. So this is the T we're looking at because this T value is not on the axis. So what do? We make a right angle triangle. Okay, so that's your X, and that's your Y. So for X, so if you use some trigonometry, this will be at parallel angles, that'll be 30 degrees. So X equal T cos 30 degrees. That will be √3 over 2T. And for Y, that will be T sine 30. Sine 30 is a half, so it's a half T. So after we've done that, we can draw, a force diagram. Now this becomes optional. If you can see it through, you can skip this. But if you can't, let's go through it. So on this force diagram, we're going to put in all the forces on there. So first of all, we'll put the forces that are on the axis. We've got T pointing upwards. We've got 8 Newton pointing leftwards. And we've got our weight pointing downwards. Now, for the T that we have resolved, this T, we have resolved X on the right side. We've got √3 over 2T. Upwards, we've got a half T. So put a half T on there. So just highlight for you. So this half T and √3 2T are here. So all the forces are included. Now we can go on and proceed. Upward force equals downward force, left equals right. So step 3, up equals down, T plus a half T equals W. Before we move on to the next equation, 1T plus a half T is 1.5T equals W. Can't do much. So the second equation, left equals the right. So left, we've got 8. Right, we've got root 3 over 2T. So therefore, T will equal to 8 times 2 divided by root 3, which is 9.24 Newton. So once we know T equals 9.24, we can bring in here. Remember, use the full value in the calculator. So in the calculator, you should have 8 times 2 over root 3 in the calculator. So W equals 1.5 times 9.24, which is 13.9 Newton. Now the accuracy in mechanics is the accuracy in the value has to be very precise in mechanics. So what you should be doing is you should be always using full value. Imagine you are an engineer, you are designing an architect, you are building a 80-story high. So one day you become a very proficient, really good architect, a well-known architect. Then you build a 80-story building on Dubai because Dubai has lots of money. They do weird things. So you've got 80 story in there, and then you make some rounding error from this first step. So can you imagine the people standing on the building being wobbly on the 80th floor? So every little decimal does count in the mechanics calculation. Unlike statistics do care less about the decimal points, because if I tell you the probability of me being a good teacher is 0.01 compared to, if I tell you the actual probability of me being a good teacher is actually 0.01. What's the difference in that? Oh, actually not 0.01, maybe 0.011 more decimal. Does it make a difference? Or 0.19, does it make a difference? Not really, because having 1% and 1.9% doesn't make away the difference that I'm not a good teacher. Of course, I'm kidding. I'm a very good liar and a very bad teacher. Right, so next one. So that's the answer. Anyway, so what we're trying to do is same thing. Put in forces, and then force diagram, resolve any forces, left equals right, up equals down. Voila. Next one. A mass of 3 kilograms, so a bit more, rests on a smooth plane, which is inclined with an angle 45 degrees horizontal. The mass is attached to the cable, which passes up the plane along the line of greatest slope and then passes over a smooth pulley at the top of the plane. Now, a lot of words, difficult words in here. Along the greatest slope. It's like one of those language, one of those language you'll use when you struggle with words in a coursework. So line of greatest slope, what does that mean? That means it's moving along this line, essentially. Okay. And then passes over smooth pulley on top of the plane. We can say pulley in there. The cable carries a mass of 1 kilogram. So that's 1 kilogram. That's 3 kilogram. Suspended on the other end. The masses are modeled as particles. The cable is a light and external string. There is a force of P Newton acting horizontally on 3 kilogram mass, and the system is equilibrium. We love the word equilibrium. Okay, equilibrium. Because up equals down, left equals right. Okay, right. That diagram is not good enough in my own eyes, so I'm going to draw my own one. It's a lot better, trust me. So 45 degree in here. A block of mass, I like to use 3 kilogram, a rectangle for 3 kilogram for a block of mass, passing through a pulley. We've got 1 kilogram in here. Okay. We've got P Newton going to the right. Now, this is quite a complicated question. If you see this in an exam, this could easily be a 10 mark or 30 or 12 mark question, right? So, I would like you to use a pencil to put in as many forces as you think that will be suitable for the 3 kilogram and for the 1 kilogram respectively. So there are some forces acting on 3 kilogram. Remember, 3 kilogram is on the inclined plane. 1 kilogram is just a free hanging object. So I would like you to put down the forces acting on 3 kilogram and 1 kilogram. Use a pencil because in case you got wrong. Okay, you can pause the video, try to draw the forces, see if you're correct with me. Okay, so I'm going to tell you the forces one by one. First of all, on the 1 kilogram, you should have 1G downwards because that's a weight, and then tension pointing towards the pulley. Because if you ignore the left part, it's actually a pulley that hangs the 1 kilogram. So the pulley, imagine pulley, it's like a hand, okay, you got fingers in here. So the pulley is actually dangling the 1 kilogram underneath it. It's like doing weightlifting, doing a little bit of gym. Right, so the tension is always pointing towards the pulley. Now for the 3 kilogram, it's on inclined plane, so the 3 staple forces, 3G cos 45, mg cos theta, mg, 3G sine 45, mg sine theta, and the reaction. Anything else is extra. Okay, so these 3 must be there. Now what else? Tension also pointing towards the pulley. And is it smooth plane? A smooth plane means no friction. So no friction. But you can imagine, could it be rough? Yes, it could be. So imagine it's a rough plane. That's actually the next chapter. Then things will become messier. It's a big chapter of calculation. But I'm not going to spoil the fun for you. So let's focus on this one. One matter at a time. So we've got 2 particles. So where are the x's then? So these are all the x's. Sorry, these are all the forces. So for the 3 kilogram, that's the x's. Okay. And for the 1 kilogram, that's the x's, because 1 kilogram is just vertical. So 2 x's for different particles. For 3 kilogram, you tell me, do we have to resolve any forces? What? Yes. So I pretend I could hear your answer. I couldn't. Right. The answer is yes. We have to resolve P Newton. Okay, we have to resolve P Newton because P Newton is not on the axis. What about on the 1 kilogram? Any forces we can resolve? No. Okay. So T and 1G are on the axis, so we don't have to resolve any forces. So let's do it one by one, block by block. Let's focus on the 3 kilogram block first. For a 3 kilogram block, okay, so I'm going to write down things I'm telling you in here. So we're going to consider 3 kilogram block. So we'll do the 3 steps, and then we'll do the 1 kilogram block, okay, and then 3 steps. So 3 kilogram blocks. You can do the 1 kilogram block first. At first, it doesn't really matter in English. 1 kilogram block first. But I want to do the harder one first, and the easier one will come later. So you build your confidence. So you always focus on the hardest thing first, and then you can move on to the easier things. So, and then later on, you find the flow of the question. So P Newton, it needs to be resolved. So where's the resolving part? Now that's it. This is the x-axis. This is the x-axis. So we're going to make connection with the x-axis, right? And that will be 45 degrees in here. To go, P Newton is going to right. So x will have, so y going down and x going up. Right? So P Newton, let's resolve P Newton. So for 3 kilogram block, resolve P. I'll just draw the triangle out again, just for this time. That's quite ugly triangle. If I say it's ugly, it's pretty ugly. So that's P Newton. That's x, and that's y. That's 45 degrees. So x equal P cos 45. That's root 2 over 2P. Y, P sine 45, which is root 2 over 2P. Right, next step, force diagram on the 3 kilogram block. So force diagram. Sorry, as I've told you, this board is a little bit sensitive. So yeah, if you see some weird highlighting like the arrow, like what I did in here, I don't know what happened to the board. So let's put in all the forces. First of all, on the y-axis, we have reaction going up, and we have 3G cos 45 going down. What else? On the P Newton, we've got a root 2 over 2P going down. So we've done that, we've done that, we've done that. Next one, we need the 3G sine 45 sliding downward, 3G sine 45 going downwards. Upwards, we've got our root 2 over 2P on the x. for the resolving part of P. So this root 2 over 2P is here. This root 2 over 2P is here. So that's what I'm saying. The direction of the X and Y matters. Next step, up equals down. Oh wait, hang on, something missing, tension. Oh, I nearly forgot about tension. The little T, tension. So have I include all the forces? Yes, I did. So now I can do the calculation. Left equals right, up equals down. We'll focus about the 1 kilogram later. So we'll just do up equals down. Up because for the Y is that way. So equal. So we've got upwards equals downwards. So upwards we've got R equal 3G cos 45 plus root 2 over 2P. It looks like something we can't solve it yet. So I'm going to do 3G, 3 times 9.8 cos 45 in the calculator. It gives me ugly value. So maybe I'll just keep it as it is actually. Next, left equals right. So leftward force is 3G sine 45. So 3G sine 45 equals upwards or rightwards T plus root 2 over 2 T plus root 2 over 2P. 3G sine 45, nope, ugly again. So I'm going to leave it like this. Is there anything I can do? Probably not. So I'm going to make this the equation 1, the equation 2, and I'm going to come back to it later. So we have done everything that we can on the 3 kilogram block. We have followed our 3 steps. Step 1, resolve any forces not on the axis. Step 2, force diagram. Step 3, upwards equal downwards, left equals right. There are too many variables in each of these. There are R and P for the first one. For second equation, we've got T and P. So there are 3 variables in here, so it's unsolvable right now. So what can we do? It's time to call our friend 1 kilogram. Let's call for help. So if you feel like you've done the mission on the 3 kilogram block, it's time to move on to the 1 kilogram block. So for the 1 kilogram block, follow the 3 steps again. Do we have to resolve any forces? Nope. Do we need a force diagram? If you really want to, yes, we can have 1 T and 1 G, and that's it. And next step, up equals down. There's no left and right because there are no forces on the x-axis, so T equals 1G. So 1 times 9.8 is 9.8. So our friend came to rescue. We now know T is 9.8 Newton. So now you see, I haven't actually read the calculation part from the question because I know by following this method, I will take every box is what they need, whatever they need. I'll find whatever they need. Okay. So T is 9.8. Let's sub it into equation 2. So sub into equation 2. So 3G sine 45 equal 9.8 plus root 2 over 2P. I'm going to make P the subject, so I'm going to remove the 9.8 to left-hand side. And I can divide root 2 over 2 to the left-hand side. So actually, let me write P. So P equals 3G sine 45 minus 9.8 as a whole big bracket divided by root 2 over 2. So that's what I'll put in the calculator. So 3 times 9.8 sine 45 minus 9.8 divided by root 2 over 2. You should put in calculator once, see if you got an answer, same as mine. I got 15.5 Newton. I'm going to store this value in A. Okay, I'm going to store this value in A because there's no exact value. Remember, you're an architect. If you do not use a full value, you're going to kill people on the 80th story. Right, next one. So P equals that one. Next, you can sub into equation 1. So now you know P, so you can sub into equation 1. So sub into 1. So what's equation 1 again? Equation 1 is 3G cos 45. So R equal 3G cos 45 plus root 2 over 2P plus root 2 over 2P. So 3 times 9.8 cos 45 plus root 2 over 2 times the value of P, which is my A answer. I got R equal rounded to 3 SF, 31.77 to 31.8 Newton 3 SF. Right? And that's the answer. So what have we done today? Is that all? Yep, that's all. Quite a big chapter, big sub-chapter, big lesson. First step, okay, put all the forces in there and then resolve if they're not on the axes. Force diagram, up equals down, left equals right. Nice. Next, if it is a more complicated question with pulley, okay, don't fret, step by step, clear your mind. Think about what forces are on each block. So for the 3 kilogram block, because it's on an inclined plane, we know reaction, mg cos theta, mg sin theta. All right. Also, because there's a strain, the tension going upwards. For the 1 kilogram block, we've got tension pulling upwards and the weight acting downwards. Next step, for the 3 kilogram block, you draw a pair of axes, okay, or you can see invisible pair of axes. I do have to write in there just to let you visualize it, but in exam, you don't have to. You understand P is not on the axis, so we have to resolve P Newton. Resolving means drawing a right angle triangle on the x-axis. Now, do write it down next to when you say resolving, that's what I'll be using. If you don't know what resolve means, you should have a note, you know, a little note tip next to it. What does resolve mean? Resolve means draw a right angle triangle on the x-axis and put an x and y and find the x and y like this. Once you've done that, draw the force diagram for the 3 kilogram block, include all the forces. Make sure you do like a checklist. What I did after I include that force, I put a tick next to it. So I know I've included all the forces in there. Once you've done that, upwards equal downwards. So R equal 3g cos 45 plus root 2 over 2p. Left equals right. So 3g sin 45 equals t plus root 2 over 2p. Realize this problem cannot be solved. 3 variables, 2 equation. We need to call in our friend to help. 1 kilogram block. Force diagram if you want to. Up equals down. And then it's just, and then from there, it's just simultaneous equation. So every time calculation will be different. And then now I've got one last step, important step, which is to read the question. Have I answered all the question yet? Calculate magnitude of P. Have I found that? Yep, 15.5. Done that. Oops. Oh, they won't let me do a take. Cheeky. Right. The normal reaction between the mass and the plane. So normal reaction means value of R. Yes, I found that as well in the last part. C, I haven't answered this. A one-mark question, which we all hate. State how you have used the assumption that the pulley is smooth in the calculation. Now, the way I like to approach this is obviously you can remember the answer. You should as well, but also you should understand why the answer is this. First of all, the pulley is smooth. That means it's not rusty. There's no friction in the pulley. Okay, so it's like a bolt head, like a head, a very shiny bolt head. There's no friction when you touch on it. It feels silky smooth. It actually sounds disgusting. Anyway, next, if there's no friction there, it means all the tension passing through from one end to the other is the same. So for our answer in part C, it will be, I'm just reading my notes just to make sure I don't give you the wrong answer. Yep, so the tension, yes, that's right, part C. The tension is the same on both sides of pulley. Okay, that means whatever you push in there, it'll be the same encountered on the other end. So that's the when a pulley is smooth. All right. You might also be asked about, can you state the assumption that the string is, where's the string? Where's the string? Yeah, inextensible string. So the assumption about inextensible string is that the acceleration is the same on both sides of particle. It's the same for both particles. It's the same for both particles. We'll have a look in that in the next chapter, 7.3, 7.5. Okay, so a big one today, but that's the 7.2.